You know how sometimes you just really need your tech to work, just like
Right.
seamlessly.
Yeah.
Like you need your phone to turn on right away. You need
Yeah.
your apps to just like do what you expect them to do every single time.
Yeah.
Like that need for things to work predictably is what brings us to today's deep dive, which is reliability testing in software.
Okay.
So for you, the learner, we're going to be sort of peeling back the layers and looking at how software actually becomes that kind of dependable workhorse that you trust.
Yeah. So we went through a bunch of articles, outlining the principles,
Yeah.
and the different methods used
It's okay.
to make sure that software is not just functional, but
Right.
that it consistently performs without,
Yeah.
without a hitch, without any problem.
Without a fail. Yeah.
Yeah.
So that's the goal. And what we're going to try to do today is sort of extract those essential ideas,
Right.
understand why reliability is so important, and look at the different ways developers and testers try to approach it, and
Yeah.
all while keeping things clear and understandable and not going down into the weeds too much,
Right.
too many technical details.
Yeah.
So with that in mind, I think the first thing we need to tackle is just like, what exactly is reliability testing?
So reliability testing, it's a set of activities
Yeah.
designed to figure out if software can operate, without failure in a specific environment
Yeah.
over a period of time.
Okay, so that's the key. Without failure.
Without failure.
Right.
Yeah.
So it's got to work every time.
Exactly.
Right. So, I mean,
Yeah.
we think about things that are reliable in our everyday lives.
Right.
Your car,
Yeah.
you turn the key, you expect it to start.
Every time.
Right. So it's the same kind of idea with software.
Yeah. It's the same concept.
But we need to know that it's going to deliver.
Yeah.
Right.
Yeah.
The expected outcome every single time it's used.
Exactly.
Um, And one of the articles, I thought this was a really good example, talked about, a computer
Right.
on a shop floor or something.
Yeah. Right. That's a good one.
It needs to just work.
Yeah. I mean, it's all about quantifying that
Yeah.
probability of it
Right.
performing correctly.
So, if they say, well, there's a 99% probability that this PC will run for 8 hours straight without crashing,
Yeah.
that's real world reliability.
Yeah.
Right.
Exactly. Yeah.
So it's more than just squashing bugs.
Right.
It's about making sure the software is robust enough.
Yeah, and making sure that it meets the customer requirements
Yeah.
in terms of reliability.
Exactly.
So they, have certain expectations of how reliable the software should be.
Right.
And it's up to us to make sure that
That it meets those expectations.
we reach that. Yeah.
Yeah. Yeah.
And it's not just about checking that it functions, it's about really getting in there and identifying potential weaknesses
Yeah.
in the software.
In the design of the software.
Yeah.
In the underlying functionality.
Yeah, and it's about finding those, weaknesses that could lead to failures down the line.
Right. Right. So
Right.
you're sort of being proactive about it.
Yeah,
Right.
yeah,
You're not just waiting for things to break.
exactly.
Now, when we think about, what impacts
Yeah,
how reliable a piece of software is,
okay.
what are some of the big factors that play a role in that?
So I would say the main two influences are
Okay.
first, the number of faults or bugs
Right.
that are, in the code.
Right. The more bugs, the more likely it is to break.
Okay. Yeah.
Right.
More flaws means a greater chance of, failure.
Makes sense. Yeah.
And then the second critical factor is the way users actually interact with the system.
Okay. Right.
So, different usage patterns can reveal vulnerabilities
Right.
that might not be apparent under, normal testing conditions.
Right. So someone who just uses like a few basic features of a program
Yeah.
might never encounter a bug
Yeah.
that someone who's like really pushing the limits of the software is going to run into all the time.
Exactly.
Right.
Okay.
Okay.
Yeah.
So we know that software testing in general happens at different stages of the development process.
Yeah.
Right. So is reliability testing something that only happens
Yeah.
at the very end, or how does
Yeah.
that work?
Not at all. So especially with complex software,
Right.
reliability testing is really an ongoing process.
Okay.
And it takes place place at various levels of integration.
Okay.
So it starts typically with unit testing,
Yeah.
which focuses on
Little
individual
chunks of code.
components of the code. Yeah.
Right. Okay.
Um, and then it moves to assembly testing,
Oh, okay.
which looks at how those components interact with each
Oh,
other.
there, got there. Yeah.
Yeah, and then you've got subsystem testing, which
Bigger chunks.
larger integrated parts, and then finally, system level testing,
Right.
which evaluates the entire software product as a whole.
The whole thing all together.
Yeah. So
Okay. So it's like building a house.
right.
You know, you check the foundation, you check the framing,
Yeah, exactly. It's like building in checks.
you check the plumbing, you check the electrical
Yeah.
before you put it on the roof. You know what I mean?
Exactly. Yeah.
So it's that kind of a multi-layered approach
Yeah.
to building in reliability.
Yeah.
Now, when development teams actually do this,
Yeah.
what are they actually aiming to achieve? Like,
Yeah.
what are the goals of reliability testing?
So there are, a number of important objectives. One is to identify patterns in recurring failures.
Okay, so are there certain things that seem to cause the software to crash?
Yeah, so you're trying to see, are there specific user actions or system states
Right.
that consistently trigger crashes or errors?
Okay.
Another objective is to measure how often those failures occur,
Right.
within a given time period.
So, yeah, how frequently is it actually breaking down?
Yeah, so this helps us put a number on the software's reliability.
Yeah.
We can actually say, okay, it fails, this many times per hour of use or whatever.
Right. Okay.
And then teams also aim to pinpoint the root cause of these failures.
Yeah, like, why is it actually breaking down?
Yeah.
Okay.
And so that the developers can
have address
address the root issues.
Yeah.
And then critically, reliability testing is used after bug fixes have been implemented.
Right. So you fix one thing, you got to make sure you didn't break something else.
Exactly. Yeah.
Yeah. So you want to make sure that those fixes haven't introduced any new problems.
Like a software game of whack-a-mole almost.
Yeah. Yeah. Exactly. So,
Okay.
and the sources also mentioned that even after a software product is released to users,
Okay.
efforts to improve reliability continue.
Oh, so it's not just like a one-time thing.
No, it's an ongoing thing.
You ship it and you're done.
Right.
Okay, so even once it's out there, they're still working on making it more reliable.
Exactly. Yeah.
Okay.
So techniques like trend analysis,
Okay.
which is looking for patterns
Right.
in reported issues over time.
Okay, so seeing if certain problems keep cropping up.
Exactly.
Okay.
And orthogonal defect classification,
Okay.
which is a structured method for categorizing
Okay.
and analyzing defects,
Okay.
are used
It's all about like tracking what's going wrong.
figuring out why it's going wrong,
Right.
and then using that to improve the software.
Yeah, to drive ongoing improvement.
Right. Okay. So it's not just a pre-launch checklist item.
Right.
It's
a commitment to
an ongoing
stability.
Right. Yeah. Okay.
Yeah.
Now the articles also talked about different types of reliability testing.
Right.
Can you walk us through some of the key approaches?
Sure. So the main three types that were highlighted were feature testing, load testing, and regression testing.
Okay.
So feature testing is pretty straightforward.
Okay.
The goal is to ensure that every function or operation of the software is executed at least once.
Okay, so you're making sure that like every single thing in the software.
Yeah, so you basically test all the
works at least once.
the individual features.
Right. Okay. And like one at a time, basically.
Yeah, the interactions between the different features are minimized during this check.
Right.
And then each feature is verified to make sure that it operates as expected.
Okay, so you're not really testing how they work together yet.
Yeah, that's a later stage.
You're just making sure each thing kind of works in isolation.
Right. So you want to confirm that
Basic functionality is there.
the basic functionality is there. Yeah.
Right. It's like testing each button
Right.
and lever in the machine
Yeah.
before you try to use the whole machine.
Exactly.
Okay.
Yeah.
What about load testing?
So load testing.
That sounds like it's about pushing the system to its limits.
Exactly. Yeah. So it focuses on evaluating
Yeah.
how the software performs when it's subjected to like the maximum workload
Right.
that it's designed to handle.
Like the most people using it all at once.
Yeah, or the most data being processed.
Yeah, right.
So the articles pointed out that,
Software might work perfectly under normal use.
Yeah.
But as the demand increases,
Right.
the performance can
Right.
degrade
Right.
sometimes dramatically.
Right. Okay.
So load testing helps us identify those,
Breaking point.
there's breaking points.
Yeah.
Yeah.
Right.
Like where it transitions from working to breaking.
Yeah.
And any performance bottlenecks
Okay.
that might arise.
So it's like, how many people can you have on a website before it just crashes?
Exactly. Yeah.
Yeah.
Or,
Okay. Yeah.
how much data can it process
Right. Yeah.
before things start slowing down?
Okay. And then the last one, regression testing.
Right. Yeah.
That's the one that I think a lot of people are at least familiar with the concept of.
Yeah. Most people who've used
Even if they don't know the name.
software. Yeah.
They know that,
We've been through a few updates. Yeah.
when you update software,
Yeah.
sometimes it breaks other stuff.
Yeah. That's what regression testing is for.
So the primary purpose is to ensure that any new bugs
Okay.
haven't been introduced.
As a result of fixing other bugs?
Yeah, so as a consequence of fixing existing bugs
Okay.
or implementing new features.
Right.
So,
All right. So that's essential.
yeah, it's essential, yeah.
You don't want to solve one problem and create 3 more.
Yeah.
Right.
You want to have that safety net
Yeah.
to confirm that solving one issue
Yeah.
hasn't created new ones.
It's like batching a hole in your roof and then
Yeah.
creating a leak somewhere else.
Exactly, yeah. So, we've talked about the different types of testing, but like the actual process of doing this
Yeah.
sounds like it could be a pretty big undertaking.
Yeah. So the articles emphasize that.
Yeah.
Because reliability testing can be quite resource intensive.
Okay.
Um,
Like it takes time, takes money.
time, people. Yeah. Money.
Yeah.
Careful planning
Yeah.
and management are essential. Okay. So what are some of the things that they have to do?
So this includes things like defining clear reliability goals.
Okay. So what are you actually trying to achieve?
Yeah. What do you want to see?
Huh.
Creating what's called an operational profile,
Okay.
which is basically it's a blueprint
Okay.
of how users will
Use the software.
interact with the software.
Okay. So it's like understanding how people actually use it.
in the real world, yeah.
Right.
And then planning and executing the tests
Okay.
based on that profile.
Right.
And finally, analyzing the results
Right.
to guide future development
Right.
and testing.
So you test it, you look at the results, and you use that to inform.
Yeah, to figure out what needs to be done next.
Right. Yeah.
Yeah.
So that operational profile sounds really key.
It is, yeah.
Right. It's not just about,
You can't just randomly test it.
poking around.
Yeah,
Right.
it needs to
You
be.
got to be systematic.
Yeah.
And you got to try to,
Simulate.
right, mimic how people are actually going to use it.
Exactly. Yeah.
So, you
It
got to
is.
think about, like, if you're testing a website,
Right.
Which buttons do people click the most?
Yeah.
Which features do people use every day?
Exactly. So you want to focus your test
Focus
there.
on the things that are going to get used the most.
Yeah, yeah. On the high traffic areas.
Right. Okay. So the sources we looked at also kind of broke reliability testing down into 3 main areas:
Yeah.
modeling, measurement, and improvement.
Mm-hmm.
So let's start with modeling.
Okay. So
What's the basic idea behind modeling?
software reliability modeling. It involves using mathematical techniques
Okay.
to predict
Okay.
or estimate
Okay.
the reliability of the software.
Okay.
And it's generally split into 2 types. You've got
Okay.
prediction modeling
Okay.
and you've got estimation modeling.
Okay. So what's the difference?
So prediction modeling uses historical data,
Okay.
often from previous projects.
Okay. So you look at how reliable
Or similar systems.
other software has been in the past.
Yeah, yeah.
Wow.
And you use that to forecast
To try to predict that.
the future reliability
Okay.
of the software.
Okay.
And this is typically done fairly early in the development cycle
Okay.
before extensive testing.
Okay. So it's more of like a
Yeah.
kind of a guesstimate based on past experience.
An educated guess, yeah. And then estimation modeling
Right.
uses data gathered from the current
Right.
software development process.
Okay. So you're looking at
Later.
the data from the actual software that you're building.
Yeah, later in the life cycle.
Okay.
And that's used to predict the current or near future.
Okay, so it's more of a snapshot
Yes.
of where things stand now.
Right. So prediction is looking forward based on the past. Estimation is looking at the present and near future.
Right.
Based on current data.
Okay, that makes sense.
Yeah. Now.
And the articles made it clear that no single model
Right.
works in every situation.
Right. It's not a one size fits all.
Yeah. So choosing the right model involves making certain assumptions about the software.
You're making simplifications about how the software is going to behave.
Exactly.
Yeah. Okay. So it's not like a perfect crystal ball.
No.
But it's a way to make some educated projections.
Make informed projections. Yeah.
Okay. What about the second category, measurement?
So measurement.
How do you actually measure how reliable something is?
Yeah, so that's a really important point.
Yeah.
Because software reliability can't be directly observed.
Right. It's not like you can put it on a scale.
Yeah.
Right.
We can't measure it.
How do you do it?
So what we do is we assess it.
Mm-hmm. By measuring
related factors.
Related factors. Yeah.
Okay, so you're looking at things that are
Yeah.
kind of proxies for reliability.
Exactly. Yeah. So current practices for software reliability measurement fall into 4 main categories.
Okay.
You've got product metrics, project management metrics, process metrics, and fault and failure metrics.
Okay, so let's break those down.
Yeah.
What are product metrics? What do those tell us?
So product metrics focus on the characteristics of the software itself.
Right. So what's the software actually like?
Yeah, what is it?
Right.
So this includes measures like software size.
Sure.
Often
how big is the program?
Yeah, often expressed in lines of code or LOC.
Okay.
And
but you're only counting the actual code.
Yeah.
Not comments and stuff.
It's only the executable code.
Okay.
Another important metric is the function point metric, which tries to quantify the functionality that's delivered to the user independent of the programming language.
So it doesn't matter what language it's written in.
Exactly.
Okay. Yeah.
And it does this by counting
different things in the program.
Yeah, user inputs, outputs, data files, that sort of thing.
Okay.
Then you've got complexity-oriented metrics.
Okay.
Which assess the
complexity?
Yeah, the intricacy of the program structure.
So how complicated is the actual underlying architecture of the software?
Yeah, and then finally, test coverage metrics.
Okay.
Estimate the proportion of the software that has been tested.
Okay, so how much have you actually checked?
Yeah, so this gives an indication of how thoroughly the software has been verified.
Okay, so these are all kind of different ways of looking at
Yeah, these are different
the inherent characteristics of the software. That might affect reliability.
Exactly.
Right.
Yeah.
Okay, so size gives you an idea of how complex it potentially is.
Yeah.
Functionality is what does the user actually get out of it?
Yeah.
Complexity metrics are how complicated is the underlying structure, and test coverage is just how much have you actually checked.
Right. Yeah.
Okay, what about project management metrics?
So project management metrics.
How do those play into reliability?
Yeah. So research has shown that there's a strong link between effective project management practices and the reliability of the software.
Okay.
So,
So how well you manage the project
good plan.
affects how reliable the software is.
Yeah. Proactive risk management.
Okay.
And solid configuration management. All this create a
good environment for building good software.
A more stable and controlled development environment.
Yeah.
Which,
So it's not just about the code itself.
Yeah.
It's about the whole environment.
Yeah. Reliability isn't just coded in.
Yeah.
It's managed in. So strong.
So good management.
Project management
leads to better software.
Lays the groundwork for more dependable software.
Okay, interesting. So it's not just about the technical aspects.
Right.
It's about the whole kind of the way the project is handled.
The whole process.
Yeah. Okay. And then we have process metrics.
So process metrics.
What do those tell us?
Yeah. So the quality and maturity of the software development process have a direct influence on the the reliability and overall quality of the final product.
Okay.
So,
but if your development process is kind of messy,
yeah, process metrics help organizations.
That's going to lead to buggy software.
Yeah, to monitor and continuously improve their development processes.
So you want to have a clear process.
A well-defined.
That everyone follows.
Yeah. And consistently followed process.
Okay.
Reduces the likelihood of errors.
Okay.
In the first place.
Yeah, if it's chaotic.
Yeah, so if it's chaotic,
you're going to introduce more bugs.
Yeah, that's a breeding ground for bugs.
Right, okay. And then the last category is fault and failure metrics.
So fault and failure metrics,
Yep.
These are specifically used to gauge how free of defects and failures the system is.
Okay.
So they involve tracking the number of faults that are found during testing.
Right.
So that's before release.
Okay.
And then the number of failures that are reported by users.
Okay.
After the software has been...
After it's out in the wild.
Deployed, yeah.
Okay.
So this data is then analyzed to assess the software's reliability in real-world use.
Right, so you're looking at both.
Yeah.
How many problems you found before you shipped it.
Right.
And how many problems people are encountering after they start using it.
Yeah. So, and this is where we encounter terms like...
Right, like MTBF.
MTBF,
and
MTTF,
MTTR, right?
Yeah.
So software reliability is often quantified using what's called the mean time between failures. Or MTBF. And the MTBF is the sum of the mean time to failure. Or MTTF. Which is the average time between consecutive failures.
Okay, so how long does it run on average?
Yeah, so on average...
Before it breaks down.
How long will it run? Before it fails. And the mean time to repair. Or MTTR. Which is